Hello, 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 hello. Voice check, voice check. Hello, 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 hello. Voice check, voice check. Cool, guys. Um, Back with another stream. So today we are going to look at this 442 weekly contest. Uh, this is just give me a second. So this is a 442 contest without wasting any time. Let's go ahead and start solving it. Virtually we'll be able to see how many we are able to see. The goal of this stream is just to learn. It's by no means I'm expert, right? Just see how many I am able to solve. What is our progress? Let's go. So I'll reduce this a little bit and change this to Java. I'm going to use Java. So you are given so you were given a positive integer n representing n dash n cargo deck. Sorry, I was drinking something. So you were given a positive integer n and there is W3. So n plus cargo deck, each cell on the deck can hold, there are n and can hold exactly weight W. However, the total book if loaded onto the must not exceed max capacity maximum. So what is this question? So basically there are 4 containers dash 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 and then each has maximum 3 weight. So each container can have, so that is like, and max weight, that maximum capacity can be 15, right? So first of all there are n slash n containers which becomes 4 in this case, and then each can have 3 weight, right? So each can have 3 weight. So 3 into that is the maximum weight that you can have, that is less. Now here there are 9 and each can have 5 weight. So 9 into 5 that becomes 45, right? That is the weight and 9 cells are there if you put, but 45 you can't add. So what is the multiple of it? See, you have, each has 5, right? So you can either say 5, 8, 5, 7, right? You can, so number such that is less than equal to 20, max weight is 20. So here 5 into x is less than equal to 20. What is the variable here? 5 is the variable, right? I think 4 would be the answer. So basically, uh, yeah, I think so. The answer would be return mat.min of n star n or max weight by W. should be the answer. 4, 4. Yep, nice. Good that I was able to solve it within one line. Cool. So the next problem is you are given a 2D integer properties having dimension n cross m and integer k. Define a function intercept such that you are given a properties of n star m, okay, and an integer k. Define intersect a and b returns number of distinct integers common to both array A and array B. Array A and array B, right? So what is array A basically here? What is array A? What is array B? That is the question. What are these, right? Uh, Construct an graphic graph where each index corresponds to property I, okay. And there is an edge between node R and J if and only if returns the number of if intersect of return the number of connected components in the resulted graph. What is this question? So there is a edge if and only if intersect of properties of I is greater than equal to k. What is intersect? That is define a function that is also return number of distinct integer. Okay, that is the common integers. Okay, that is doable. That is there is an edge between properties I. Construct an graphic graph where each index I corresponds to properties of I corresponds to 1 comma 2. So there are these many edges, right? And there is an edge there is an edge between I and J. Edge between 0 and 1. So there is an edge between 0 and 1. There is an edge between. So basically these are our nodes. 5, 6 and 7, 7, right? And k is equal to 1. So we need to find whether which of these are edges. Edge is there and edge can be bidirectional. So first I can create the edge between these two. So 0 and 1 is 1. Is 0 and 2, there is no common element, no common element, no common element. All the common elements has graph, right? So then I would have formed a graph. Then to find the connected components, I'll just do a DFS. Or is there other way to do a connected components basically? And then do a DFS, right? To find the connected components. Yeah, I think this also is easy. So list integer, list as integer graph is equal to new array list, right? Int nodes, int n is equal to properties dot length, and m I don't really care about. So what I'm going to do is for int I is equal to n, for int j is equal to I plus 1 j less than n, j plus plus, basically I to j and j to I would also be there. So I need to find unique numbers, right? So what I can say is hash set integer hs is equal to new hash set, or another way would be that if I just sort it, number of distinct common integers I want to find, right? Yeah, let's do it in a sorted way. So arrays dot sort properties dot I, right? Arrays dot sort properties of j, int common is equal to 0, and int ij k is equal to 0, kl is equal to 0, while k is less than properties of I dot length, and l is less than properties of I dot length, while these two are less, right? What we would do is if properties dot I comma j is equal to properties, so k here also k, l, if these are, so first thing, right, this is not going to be I and j. Yeah, better would be if I just put both of them in hash set, and then yeah, that is better actually. So let's do it that way, simpler. This one is equal to new hash set hs2 is equal to new hash set. Not sure if I can put properties of I comma properties of I here and properties of j here. Let's see if this gives an error. Return 0. New hash set. Okay, this gives an error. Okay, this is not the right. I made the same mistake. So what I would do is for int p in properties of I hs1 dot add p, for int j in properties of j hs2 dot add p. Right now, while hs is not equal to 0, right? So basically, now for int h in hs1, if hs2 dot contains h common plus plus, new event com is equal to 0, right? And so basically, if com is greater than equal to k, uh, graph dot get I don't want duplicates, so let's use hash set within that. Get I dot add j, graph dot get j dot add I, right? Now that's there. Right now, once you have formed the graph, you will do a DFS and you don't want to, so boolean visited is equal to new boolean and for n time is equal to 0 less than n I plus plus, if visited of I is equal to false, you do a DFS of graph I visited and mark and count plus plus int count is equal to 0, So public void dfs. What next we can do there is, so list integer graph int I int at boolean visited, visited of at true return, visited of at is equal to true, 4 and 2 into graph dot get at, if visited of 2 then you continue, otherwise you say dfs of graph 2 visited remains same and you return the count. So count plus plus. Runtime error at this graph dot get I dot add. I j is equal to I. Okay, one thing that I missed. For int. Uh, 3 1 2 3 1 2 submit. Should work fine. Cool. Minimum amount of head do I stand? I think I should stand somewhere around 5,000 because I was not quick enough to solve these. But we'll still see. Yeah, around 3,000. Why is my laptop this slow? You are given a two integer scale and mana, and each length and m. So in a laboratory, n visits must brew m potions. So there are n visits must brew m potions in order. Each potion has capacity mana and must pass through all the visits sequentially. The time taken by ith visit on jth potion. So in laboratory must brew m potions in order. So all of them 1 4 2 4 5 1 4 2, all of them must pass through all the wizard. Time taken by ith visit on jth potion is mana dot j and skill of I. So there is ith visit and each has skill. So that is this. Since the brewing portion must be passed to next unit completes their work. This means timing must be. So here the first one takes 5 minutes, right? Time taken by 0th minute is 5. Then after that time taken by second is ocean 0. Time taken by wizard 1 done by skill is 5 and mana of J is 1. That is also 5, right? Ocean has a capacity. It will take 5 minutes on first because that what it is, and the second one will also take 5. How much time this will take on the? It will take 5, 1, 4, 2, right? The second one will take 25 minutes. So that mana that will be passed to second then. So first one will take 5 minutes. Second one will take 25 minutes. The third one will take 8 minutes. It's not. Third one will take 10 minutes. Then again 20 minutes. So that first mana will be done after 60. But once this is done, why does this start at 52? Why does it not start at 50? The portion must be passed to, for example, for y visit. Okay, if time 50 it starts, uh, the wizard 3 is, so it will reach wizard 3, it will reach wizard 3 by, hmm, I see, a really nice problem. Mhm. So now the idea is that Mm. Let's see what is that. Seems like it is doable. What is this luck chart? This is not luck. It's a good problem. I think I'll have to spend some time analyzing this problem because how can we do it? I'm going to think about it. Uh, so probably let me mention that so what if we, let's say, do a brute force, right? So it will take 5 minutes, and that will take the same thing will take 1 minute, so total 6 minutes. And no, wizard wise, right? So 5 plus 25, 30. Then 2 plus 32. Man, again I'm okay. 5, 30, 40, 60, right? So this is first. Now, if you then start after 60, right? Then it would be 61, 66, 68, 72. And then let's say you go with 4, right? 22. So 76, 96, 104, 16, 120. Then go to next 122, 132, 136, 144. So this is like the brute force. If I don't do anything right, this is the brute force 144. Right now we can reduce it. Now that is the question. So this is coming at 72, right? So basically, how much potential is here? How much early I can start such that there is some distance saved, right? So here there is difference of 12, right? I need to make sure that the next element doesn't get free before it, right? So the next element doesn't get it unless it is. So this 61 can't be before 30, right? Hmm. So this 68 can't be before 60. So once I do this, I will start with this 7144. So this 166, it can't be before 120, right? So this can't be before this 60, right? Okay, so we'll take it, we'll try to reduce some context from here. So this can't be before this 60. So what we can do is let's say that okay, saving, making it 60, making this end at 60, instead of 68. So 8 I can reduce, right? Now if this one, yes, here also it can be reduced. So this will become 50, this will become 68 here, so we can make it 53. Yeah, this is done by. Hmm, I think it is. Let's read this question. Mhm. Mm, uh, But take this hint. Not sure why my laptop is this slow. But yeah. Maintain each visit's earliest free time for last portion as F5. Okay. Damn it. Pure maths I think, huh? Maths prefix simulation. Mhm. So we calculate the time to make the first portion. Okay. While doing that, we track then each visit is done with the product. For the second portion, the visit I plus 1 can start working when the visit I plus done is 1 done with the first portion and visit I is also done with the second portion. So when this is done and this is done, right? Now we need to make sure there are no delays. For that we have to go back to the last visits first and adjust done times to remove any slack. Okay. Mhm. I'm going to end the stream here, guys.